Hello. Today in this video I'm going to be showing you how to solve exponential equations using a common base. In order to have success with this type of problem, you need to know some of your rules or remember some of your rules for how exponents work. In this problem we've got 3 raised to the x minus 3 times 3 raised to the 2x is equal to 1/9 to the x minus 1. The key is getting a common base between the left side of the equal sign and the right side. Now, in this problem, since I have a 3 raised to a power and a 3 raised to a power on the left, I'm going to go ahead and make that one base of base 3. That does not become 9. All right, the base stays the same. And what we end up doing is taking the first exponent and adding it to the second exponent. So this guy becomes one exponent plus the other exponent. Bases do not change in multiplication. The exponents simply get added. On the right hand side of the equal sign, I will change my 1/9 to a base 3. 1/9 is the same as 3 to the negative 2, and my exponent stays the same up here on the outside of that set of parentheses. I have like terms in this exponent, so I'm going to go ahead and make that 3 to the 3x minus 3. And on the right side of this, remember, exponents raised to exponents will get multiplied. This is a distributive property, so I end up with 3 to the negative 2x plus 2. Since my bases match, we can actually get rid of these bases. Logic says that if 3 raised to something is equal to 3 raised to something, those powers must be the same. So I end up with 3x minus 3 is equal to negative 2x plus 2. Using my inverse operations from Algebra 1, I can go ahead and start solving this out. The negative 2x is canceled with a positive, and we end up with 5x on the left-hand side. Minus 3 is equal to 2. I go ahead and add 3 to both sides, again using inverse operations, and I end up with 5x is equal to 5. Dividing both sides by a 5 leaves me with x equals 1. There's my first example of solving by common base for these exponential equations. Hopefully this will help you work the problems that you've been given. Here's another example using some different numbers and slightly different technique. But I'm going to call this question B. 4 to the x minus 3 is equal to 1/8 to the x plus 1. That guy right there, the temptation for most of my students is try to make a base 4, when in reality we want to make a base 2. 4 is 2 squared, and 1/8 is 2 to the negative 3. Again, using my rules for exponents, I can distribute this guy in and get 2 to the 2x minus 6, and 2, make sure the negative gets distributed, the negative 3x minus 3. Since again my bases match, I can go ahead and get rid of those guys. 2x minus 6 is equal to negative 3x minus 3. Using inverse operations like I did in the last problem, I can start getting my like terms together and get 5x minus 6 is equal to negative 3. Make sure that negative sign follows you down. I'm going to add 6 to both sides. 5x is equal to 3. Dividing by 5 gives me an answer of 3/5. Just because it's a fraction doesn't mean it's wrong. That is our answer to this problem. Once we get our bases to match, we're back to an Algebra 1 level question. So hopefully these two problems have given you a little bit of insight into the problems you need to work for your class, and hopefully the video gives you a little bit of insight into how these problems work.